here's lesson 7.1 on arithmetic sequences. Our lesson goals for today, there's quite a few of them, but they're all really easy. But if we look back at the beginning, our lesson goals are going to be to explain the meaning of a whole bunch of terms, calculate a common difference, calculate the nth term, so where we specify like the 33rd or something, determine the number of terms in a sequence, determine the general term, and something called a recursive formula for a whole bunch of different things. That's going to be the body of the work today. And then also using arithmetic sequences to solve simple interest problems. You did simple interest way back in grade 7. So let's begin with some of those definitions. First one is sequence. So a sequence is a set of numbers separated by commas arranged in a specific order. So it's just the set of numbers. That's the key part there. A term is a number in that sequence. So if we had a sequence, for example, that looked like 5, 10, 15, 5 would be the first term in this sequence. 10 would be the second, 15 would be the third, and so on. We're going to use subscripts instead of writing first term. We're going to write like T1. T1 would be that first term. T2 would be the second term. Tn will be the nth term, and that's going to be the nth term of this sequence. And that's called the general term. So that's sort of like a different, Tn is the nth term of the sequence, and that's the general term. Ellipses are just the 3 dots. It means it keeps going on, and so on. So knowing what we know, if it asks us how many terms are in the sequence 5, 7, 9, 11, we literally count 1, 2, 3, 4, and we get that it's 4 terms. It then says use proper notation to write out the first 3 terms individually. So using proper notation means T with a little 1. So the first term is 5, the second term is 7, and the third term equals 9. So that's the proper notation. Example 1, done. Back to another definition. A recursive sequence is a sequence where the first term is given and the terms that follow are based on the previous term. And the terms that follow are based on the previous term. The best way to show you what this means is with an example. So with example 2, determine the recursive formula for the nth term in the sequence 1, 3, 5, 7. First thing we need to figure out is the first term. So T1, the first term in this sequence, is just 1. And then it says terms that follow are based on the previous term. So first, if my term that I'm looking at is Tn, then the previous term would be Tn minus 1. Someone's going to give me grief over that little n. So Tn minus 1. So if now I'm trying to figure out what Tn is over here. So for example, if I'm figuring out what the second term is, I'm going to take my first term or the previous term, and then how would I get from 1 to 3? Well, I could add 2. And each step I would be adding 2. So I would take the previous term and I'd add 2. So my recursive formula here is going to be Tn equals Tn minus 1 plus 2. And that's the recursive formula because it's based on the previous term. When we're doing a recursive formula, it's going to be really important. N can't be any number. It can't be like 1.5 or the square root of 2. N has to be part of the set of natural numbers, and n must be greater than 1. So that's going to be part of when we write our recursive formula. We're going to have to include all that other stuff as well. For example 2, it says then determine the general term of the sequence from A. Oh, and I've just done that. So I'm not sure, because I wrote this passage, I being Miss Hancock, I don't even remember what I was asking for there. So that would be the general term here. So we're going to leave that. Example 3, determine the general term of this sequence 1, 3, 9, 7. So somehow I'm going to have a T, N, and there's going to be something to do with the previous term. So let's take a look and see what happens. To go from 1 to 3, if I look at steps, plus 2, plus 6, plus tired, plus 18, that's not going to work. But I also happen to have noticed that they're all powers of 3. So 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. So for the first term, the second term, the third term, and the fourth term. So it looks like this is going to be not actually based on what came before. It's going to be based on n. So Tn here would be equal to, you take 3, and it's going to be raised to the power. This was n. So when n was 1, we wanted the exponent to be 0. When n was 2, we wanted the exponent to be 1. When n was 3, we wanted the exponent to be 4. So each time it was going to be 3 to the exponent of 1 minus 1, 3 to the exponent of 2 minus 1, 3 to the exponent of 3 minus 1, and so on. So my general thing would be 3 to the exponent of n minus 1. So in this case, my general term isn't a recursive term. It's just a general term. T to the n equals 3 to the n minus 1. Thanks for bearing with me. Okay. Now we're going to talk about specifically arithmetic sequences. So an arithmetic sequence is one that has the same first difference or the common difference between any pair of consecutive terms. So consecutive means one after the other. One after the other. So the formula used to calculate the general term or the nth term of an arithmetic sequence, general term of an arithmetic sequence is this. And this is going to be something we're going to use a ton. Where A is going to be my first term, and then D is going to be the common difference, and N just tells us what term we're looking at. And if we go through an example with this, sorry, not the example yet, the formula used to calculate the recursive formula, not the general term. So this one is going to be the recursive formula for an arithmetic sequence. That's going to be this whole big thing, including the restrictions on what n is. N always has to be a number 1. So then we have to include two parts here. We have to include that the first term is the first term, and then the next term is going to be equal to, or sorry, the general term is going to equal the previous term plus the difference. So with these two formulas in mind, the next one says, for the sequence 5, 7, 9, 11, ... find the following. A is our first term. So A is the first term. You don't have to write that, but A is our first term. So in 5, 7, 9, 11, our first term is 5. D is the common difference. So it'd be 7 minus 5, which is 2. And if we were going to write the general term is Tn. So the general term is going to be Tn equals, I'm going to use this formula up top here. So it's going to equal 5 plus n minus 1 times 2. And if I'm going to write the recursive formula, that one's going to be I have to say what I start at. So t1 equals 5, comma, t to the n equals the previous term plus 2 with all the restrictions. N must be a member of the set of natural numbers, and n must be greater than 1. We're not going to bother writing that out every single time, though. So we've got the general term and the recursive formula, both things different, using the same stuff. Example 5 says, given t to the n equals 3n minus 2. So I hope that by looking at that, you notice that it doesn't look for anything where it's t to the n minus 1. So this is not a recursive formula. This must be a general term because no t to the n minus 1. Just something to note. It then says write the first 5 terms of the sequence. So t1 would equal 3 times 1 minus 2, which is 3 minus 2, which is 1. T2 is going to be 3 times 2 minus 2, so that's 6 minus 2, which is 4. T3 would be 3 times 3 minus 2, which is 9 minus 2, which is 7. So if we take a look at what our first 3 terms are, they're 1, 4, 7. Each time they're stepping up by 3. So I could use the formula again, or I could say T4 is going to be 7 plus 3, which is 10, and T5 is going to be 10 plus 3, which is 13. Example 5b says determine the values of a and d. A is our first term, so that's just going to equal 1. D is that common difference, so that's going to equal 3. Remember, you can always pause at any time to copy things down or try and figure them out on your own. Example 6, given the sequence 8, 12, 16, 20, determine if the sequence is arithmetic. And what that's really asking you to do is check to see whether there is a common difference or if the step between each of the terms is going to be the same. So if I do t2 minus t1, so that's the first 2 terms minus each other, I get that the step is 4. If I do t3 minus t2, that's going to be 16 minus 12, and the step is 4. t4 minus t3, 20 minus 16, so this step is 4. So every step is always 4, so yes, it is arithmetic. For B, it says, if the sequence is arithmetic, which it was, use the formula to find an expression for Tn. So we're going to go back up. The formula we're going to use is going to be that one. Tn equals our first term plus n minus 1 times d. So our first term times n minus 1 plus d. T to the n equals our first term, which is 8, plus n minus 1 times d. The difference was 4. And if we distribute and expand, that would be fine, but it's not particularly tidy. So if we were to distribute, we would get 8 plus 4n minus 4, which equals, 8 minus 4 is 4 plus 4n. That would be our final expression for Tn. Then it says write the recursive formula for the sentence. So for recursive formula, we tell what the starting term is. So T1 equals 8. Then Tn equals the previous term, so Tn minus 1, plus the difference, so plus 4. And that would be the recursive formula. So 2 different things, but they get you eventually to the same point. Now it says use the expression to find T91, so the 91st term. And just noting that if it was in function notation, we'd be looking for f of 91, where f of n equals that same expression for Tn, the general term a plus n minus 1 to the d, this thing here. So if we want to find f91 or T91, T91 is going to equal 8. I'm just using the formula from right here. 8 plus 91 minus 1 times 4. So that's going to be 8 plus 90 times 4, which equals 8 plus 360, which equals 368. So T91 would equal 368. Next. Example 7 says, how many terms are in the arithmetic sequence -3, 2, 7, 152? So in this one, we can figure out, we know that A equals -3. That's our starting term. D is our common difference. And each time we're taking a step of +5. So our common difference is going to be 5. And we don't know what term this last number is, but if we were to write our expression for a general term, it would be Tn equals A plus n minus 1 d. So 152, we don't know what term it is, so we're actually going to be solving for n. We don't know what term it's going to be, but we know that a is -3 plus n minus 1 times d, which is 5. This is what we're going to be solving. So the first thing I'm going to do if I want to get n by itself is I'm going to move the -3 to the other side. So I get 152 plus 3, so 155 equals n minus 1 times 5. The next thing I'm going to do is divide both sides by 5. Bear with me while I use my calculator. 155 divided by 5. So I get 31 equals n minus 1. Still got to get rid of that -1, so when it goes to the other side, I'm going to get 31 plus 1 equals n, so that n equals 32. So in this question, it says how many terms? There are 32 terms. So maybe I should have done this at the beginning, but how many terms is asking for solve for n? Example 8. Find Tn. Remember, Tn is our general term. Find the general term if the 7th term is 121 and the 15th term is 193. I'm going to show you something. This is not what you do every time, but it would work for now. So if I know that my 7th term is 121. I don't know my 8th or my 9th or my 10th or my 11th or my 12th, 13, 14, 15. I do know my 15th term is 193. If I was looking at how many steps I had to take to get from 7 to 15, it would be 1, 2, 3, 4, 5, 6, 7, 8. So I will be able to figure out what D is, because 8 steps or 8D is going to be the difference between 193 and 121. So 8 steps or 8 differences is going to be 193 minus 121, which is 72. Divide both sides by 8. I get that my difference is 9. So we've got that the difference is 9. Great. But to get the general term, I need the difference and the starting value. So that was to find D. Now to find A, I can take either one of these terms. So T to the N equals A plus N minus 1 D. I'll take the first one, T7. So 121 equals, I don't know what A is, but I know I'm on my 7th number. So 7 minus 1. I know the difference is 9. So 121 equals A plus 6 times 9. So A plus 54. So 121 minus 54. 121 minus 54. So 67 equals A. So now I have D and I have A. So I can write T to the N equals 67 plus N minus 1 times 9. And that would be our general thing. We're going to simplify it. So that would be 67 plus 9N minus 9. So that would be 58 plus 9N once it's simplified. So our final answer would be 58 plus 9N. And if you were going to check if this was right, we can always use T15 equals 193 to check. So I could do T15 equals 58 plus 9 times 15. And on a calculator, 58 plus 9 bracket 15, close bracket, equals 193. So that means we were good. We did it right, and we have the correct general term. Example 9. This is the last example. Example 9 says, Temeraire invests $300 in a GIC that pays 6% simple interest per year. There aren't going to be any GICs that pay that much interest per year for a long time. So simple interest, we've got some numbers, 300, 6%. When will his investment be worth $732? Back in grade 7, you would have done I equals P times R times T. You could figure out the interest. You could figure out, because we could figure out how much it grew by, all that kind of stuff. We're not going to be doing it this time. Instead, we're going to be using T to the N equals A plus N minus 1 D, where N is going to be our number of years. A is going to be our initial amount. D is going to be how much it grows by each year. And this is where we are going to have to use the I equals PRT. So the amount it's going to grow by each year is going to be the same as our interest, which is the P times R times T. And N, A, and D. That's going to be it. So let's figure out D first. In this case, our principal amount was our initial amount, so that would be 300. The rate was 6%. That's going to be 0.06. The number of years, we're going to say this is, D is going to be the interest in 1 year. Interest in 1 year. So that means time equals 1. So it's going to be 300 times 0.06 times 1 year. And when we do that, we're going to find that each year you'd be making $18. So our step would be $18. So we start at 300 plus, we know it's going to grow to 372. We're going to solve for N minus 1 times our difference, which is 18. So I took this amount here, our difference of 18, and we put it in there. So 732 minus 300 is 432 equals N minus 1 times 18. Divide both sides by 18. So 432 divided by 18 gives 24. 24 equals N minus 1. So 24 plus 1 equals N. So N equals 25. And because they asked us in words, we're going to answer in words. Therefore, his investment will be worth $732 in 25 years. And you can always do I pretty to check. So I'm going to do this over on this side, but you won't have to. It's just going to work. So we know we wanted the interest to be, total interest was going to be 732 minus 300, which was 432. Oh, that's kind of like what we got there. And so we were going to have that interest equals our principal 300 times 300 times 0.06 times time. So that would have given us 432 equals 300 times 0.06. Hey, I know that's 18 times time. So 432 divided by 18 gave us 24 time steps. And if we started in year 1, that would mean we'd have to add 24. And in the 25th year, in 25 years, it would be 732. So we are correct. Make sure you do your homework. If you get stuck on any of the homework, you can always go back to the video. And in the comments below, or the description below this video, I'm going to put down what time each question's at so you can skip directly to each question.